Hello. Good evening, everyone. If I'm audible, please can I get an information in the chat box whether my voice is loud and clear enough or not? Okay, so I'll be waiting for like few seconds or few minutes so that everyone can join the session. Okay, so let's start the today's session. Okay, I have shared my screen and I think the screen is visible as well. So, welcome to the problem of the day, 20th March. So, the question was pretty good and it has been asked in Google as well. And the difficulty level of this question is medium. And the name of the question is shortest XY distance in a grid. Okay, so first of all, I would like to know how many of you were able to solve this question. And and a good like congratulations to all of the students who were able to solve this question, right? Okay. So first of all, let me give you the idea in which how will I proceed further. So basically, first of all, I'll explain the problem statement and then examples. And then if you are having any doubt in the problem statement, we'll have a one-to-one discussion in the chat box and I'll be speaking over here. And then we'll be taking a look at the brute force approach. What can be the brute force approach? Algorithm. And then we'll be seeing the optimized approach and then the code. And I'll be sharing the link of this code which I am doing over here in the chat box, as well as you will be finding the link in the comment section as well. Okay, and I'll be coding in Java, but if you need the code to be in C++ or any other language, do mention down in the chat box or comment section. Okay, so this question was pretty good, and yes, you need to brainstorm a little bit. Some prerequisite is required in order to solve this question. Okay, so first of all, let's read the problem statement. So the problem statement is pretty simple and pretty straightforward. So you'll be given a grid, and the size of the grid is hello Rishit. Hi Rishit. So the problem statement is pretty simple and straightforward. So we'll be given a grid n cross m sized grid and there are characters written down. So 0, x and y are the characters, and what you have to do, you have to find the minimum Manhattan distance between point x and point y. Okay, and the Manhattan distance, if you are not aware, then it is row index of x minus row index of y. Take the absolute value and add it with the difference of column value of x and y, and that is called the Manhattan distance. Hello, Anand. Hello. Hi, good evening. So, first of all, let's try to understand with the help of a problem example. Do you have any kind of doubt in the problem statement? Anyone from the audience? Yes, exactly, Anand. It's a very good problem. So, any doubt in the problem statement? Yes or no in the chat box? Quick yes or no in the chat box. Okay. So we'll move further. So now let me share my another screen. So I'll be stopping and I'll be sharing my entire screen. Okay. So let's see a test case. So I'll be writing down the Manhattan distance formula as well over here. So rho of x minus rho of y and its absolute difference with column of x and column of y. So this is what the Manhattan distance is. So over here you are given a matrix of n cross m, that is 3 cross 3 size, and these are the characters x0 0 O, O, Y, and Y, O. So basically in the question you have to find the shortest distance between X and Y, and that should be the Manhattan distance. So over here, let's try to find out the distances. Okay, so what I'll be doing, I'll be trying to find the distance, what is the shortest X for this Y. Okay, so let's say from this X, what is the distance? And I'll be noting down the row number 0, 1, 2, 0, 1, and 2. So row number, the difference of row number is uh, difference of row number 0 minus 1, and the column number. So the column over here is 2, and its column is also 2. Its column is 1. So the difference comes out to be 1 plus 1, and that is 2. And the distance of it from this is called, let's say, so we got one of the distance between 0 comma 1 and 1 comma 2, and one more distance 0 comma 0 and 1 comma 2. What will be the distance? So that would be 0 minus 1 plus 0 minus 2, and that comes out to be 3. So for this y, we have two distances, 2 and 3, and the minimum comes out to be 2. So the nearest x for this y is at a distance, Manhattan distance of 2, and this is the x. And similarly for this, if we try to find out, we'll be getting, for this it will be getting 2, and the another will be, this is 1 and this is 2, another will be 3. So both the x, one of them is at a 2 distance and another one is at 3 distance, and the minimum comes out to be 2. And among all the y, you get a minimum distance of 2, and that is the output for this test case over here. So this is what we have to do, and we have to find out that what is the minimum distance. Is it clear? Yes or no in the chat box? Was the sample test case clear to you? And how many of you were able to solve this question? Can I get a confirmation in the chat box? How many of you were able to solve this question? Okay, Rishit. Okay, so this is what we are going to do for this test case, for this question. So now I think I should move forward. Okay. Okay, Praveen Yadav. So basically, what I did, for every y, I tried to find that which is the nearest x. So for this y over here, I came to know that one of the x is at a distance 3 and another x is at a distance 2. So I chose the minimum, that is 2. For this y, the minimum, the nearest x is at a distance of 2. Similarly, I did the same thing, that which is the nearest x at what distance from this y. So I came out that two x are there and they are at a distance 2 and 3 respectively, and I chose the minimum one, minimum distance. So I came to know that the nearest x is at a distance 2 for this y, and similarly at a 2 for this y. And among all the y, I chose which is the minimum xy distance. So I had two different candidates, 2 comma 2, and the minimum comes out to be 2. Hence the minimum distance between x and y for this given grid comes out to be 2, and that's the output. Is it clear? Yes or no, Praveen? So what do you think, what can be the brute force approach? What can be the brute force approach? How can I find the minimum xy distance? So what do you think? You have time till I draw entire grid. What do you think? So basically, should I follow the same process? What should I do? Try all unique combinations. Exactly, Rishit. Yes, correct. So do you all agree with Rishit that we should try out all the combinations? Will that work? Obviously, that's a brute force, and we are not uh, skipping any of the combination of x and y, and then we'll be choosing the minimum. So absolutely, this is the correct approach, and we'll be able to solve the question in that manner. So over here you can do one thing, as the question wants you to find the minimum distance between x and y. So let's say there are different pairs possible. Let's say this is one of the pair, ith pair, okay? And among all the ith pair, among all the possible ith pair, you have to choose the minimum one among all the candidates, among all the possible I. So basically that's trying out all the combination, right? So all the possible combination of x and y, I'll be finding what is the Manhattan distance, and then just take the minimum value. For every x, we need to find distance to every y and return minimum. Yes, exactly. So what I'll be doing over here, in order to find the Manhattan distance, you need the row number and the column number, right? So you need a pair of a row and a column. So what I'll be doing, I will be creating an array list or a vector. Let's say if you are coding in Java, so you will be doing array list, or if you're coding in C++, then you will be choosing vector, right? So what I'll be doing, I'll be storing pair of row number and column number of every x in a vector called x position. I repeat, I'll be storing the pair containing row number and column number of every x in this grid in an array list or a vector, and the name of that array list or vector will be x position. So over here, this x position vector will be containing 0, 0 and 0, 1. So these are all the positions of x. And similarly, I'll be doing that thing for all the positions of y. Is it clear? Yes or no? Yes, we'll be doing that for y as well. Yes or no? Is it clear or not? Yes or no in the chat box. A quick yes or no in the chat box. So I'll be getting the idea that you are understanding what I'm trying to say. Okay. So I did it for x and y. So now I can try out all the combinations. So I'll be finding out the possibility, all the possibility. So what I'll be doing, I'll be taking the position of y 0, 0, and I'll be finding what is the distance for this position of x and y. So this is x and this is y. Similarly, I'll be doing for 0, 0 and with 2, 0. What will be whatever I'll be getting? Let's say for this I'll be getting 3, and for this I'll be getting 2. Again for 0, 1 and 1, 2. What will be the answer? For 0, 1 and 1, 2, what will be the answer? A quick reply. It will be 2. And for 0, 1, 2, 0, what will be the answer? It is going to be 3. And among all this value, what you can do, you can take the minimum, right? So this can be achieved by simply doing a nested loop over the vectors x position, and inside this external for loop, you will be having a loop which will be iterating over all the y positions. And then you will be finding the Manhattan distance and keeping a global answer variable, which will be initialized to, let's say, minus infinity. And what you will be doing, it will not be minus infinity, it will be infinite, and you will be choosing the minimum one, right? Okay, no problem. So basically, I'm discussing the brute force approach, and in the brute force approach, I'll be giving you a quick recap of what I have discussed till now. So if I want to find the minimum distance for each and every x and y position, what I'll be doing, I'll be storing the x position and I'll be storing the y position. Yes, Rishit, exactly. The time complexity is going to be order of n square. So x position and y position in a different vector, two different vectors, and then I'll be trying out all the combinations of x and y. And for each and every pair, for each and every combination, I'll be finding the Manhattan distance. And I'll be comparing it with some global answer variable, and then I'll be finding the actual answer, and whatever is stored in answer variable is my output. So basically the time complexity of it in worst case can be n square. Let's say over here y n square. Let's say at n is equal to m for some test case. So the size of the matrix, I can call it as n square, right? And let's say x position are half of the squares are n square into half are the x. N square into half are the x, and over here n square into half of them are what? So let's say they are y position, and I'll be, let's say, calling it as m. Basically, at max you can choose that there are n number of x's and n number of y positions, and over here, so it is possible that this is n number of n square by divided by 2, and over here for this you will be iterating over this many positions. So if you try to find it in the worst case, that would be n into n into n into n. So basically it's not going to be n square n into m, but n square into n square. You can call this part as n square or n to the power 4. Okay, if I take an example in which the row number and column number are same, then the time complexity will be n to the power 4, else it will be n square into m square if I denote the number of rows by a different variable. That's it. Okay, is it clear, the time complexity? Yes or no? How the time complexity is order of n square into m square. Okay, okay, Rishit, it is not going to be order of n to the power 2, but n square into m square, or you can say n to the power 4, only in terms of n. Is it clear? Yes or no in the chat box? What is n? N is the, I have taken the row number and column number same for simplicity. Okay, over here I have taken the row number and column number as n. Okay, and that is the reason I considered n to be the number of elements in the matrix. Okay, okay, then that's okay. Okay, got it. So this is going to be our time complexity. Yes, then you are absolutely correct if you considered n. I thought you were saying in terms of row number and column number. Okay, so this is going to be our brute force approach. And do you need a, let's say, algorithm for this? Anyone? Is there anyone who need the algorithm for the same? Because a simple nested for loop is required over here, or else we'll be moving further. A quick yes or no in the chat box. Okay, I see. Okay, I think there's no requirement. So let's move forward. Okay, so this is not going to be accepted, obviously. If we take a look at the constraint, where is the constraint? Over here, it is 10 to the power 5. Total number of, what do you say? Total number of elements. It is going to be 10 to the power 5. And our time complexity came out to be, in terms of n and m, it is, I can call it as n into m d power 2. So at max, n into m is 10 to the power 5. And it comes out to be 10 to the power 10 iteration in 1 second. Not at all allowed, not at all acceptable, right? So this many operations, this many iterations are not at all acceptable in 1 second. And obviously for this we don't need a brute force approach, it will not be accepted. Okay, so this many iterations, 10 to the power 10 iterations will be there in worst case. So we need to optimize a little bit. We need to optimize a little bit. So what do you think? If you have seen the editorial, I don't want the answer from the editorial, but looking at this question, what do you think? Which data structure can you use? Which concept can you use? Over here, you can see the term distance. So what do you think? Which data structure, in which data structure or in which algorithm have you heard the term distance that is useful to find the distance? What do you think? And over here for distance, we already have the formula. So what do you think? DP. Okay, no, distance is not a part of DP. Okay, so I'm trying to say this distance concept comes under the graph, right? Yes, yes, you can use any of the graph traversal algorithm, but this concept distance, it comes under the umbrella of a graph. Correct. We have heard everything that if you want to find the distance, nodes, edges, towns or towns or cities, and connecting road between them, Google Map, right? So whenever you hear the term distance, and you have a formula or anything, there is almost like in majority cases there is a possibility BFS DFS can be applied. From the eagle point of view, from the eagle view, it is possible that you will be facing difficulty that how will I modify the BFS in order to get the actual answer, but you will be able to solve it using BFS or DFS algorithm, right? And some of you already have figured out that we can use BFS. Okay, so over here I will be discussing the optimal approach. So can I get a confirmation, like what do you think, why did you guys say BFS algorithm? Why not DFS? Any reason for that? I can see the audience is like pretty smart today. So, what do you think? Any reason behind using BFS and not DFS? I see some specific reason as well. Anyone? Can I do it with DFS for minimum distance? Use BFS. Okay. BFS gives single source, shortest path in unweighted graph. Yes, Rishit. We need to check neighbor. Okay, neighbor. So basically, over here, the grid, if you observe the grid, do you see any kind of weight? Over here, if you observe carefully, I can write this entire thing in terms of a graph. It will be very interesting if you pay proper attention. See, I'm noting down this as my x. Okay, one more x is required. You'll be finding it very interesting. This is the beauty of graph. Like you can actually convert anything into graph in which you hear the term distance. Just a minute and we'll be done. Okay, fine. Now, do you think this is like a node? These are the nodes. I can call all of them as nodes, and they are having something. Let's say they are having some name. Let's say these nodes are zero nodes, and I'll be calling this as y nodes, right? So, and there is an edge between all of them. The edges are like this. Don't you think this is possible? And the edge weight over here, all the edges are unit weighted. Don't you think I can imagine this grid, entire grid in this manner? And all of them are having unit weights. So whenever you see that you can apply BFS, DFS, and you are given a matrix, then you can imagine the matrix in this way. Yes or no in the chat box? Can I imagine the matrix in terms of nodes and edges? Yes or no in the chat box? A quick yes or no. So I'll be getting an idea, so I'll be moving forward. Okay, okay, got it. So now over here, whenever you see a graph question in which the talk is about undirected graph as well as shortest distance, just think about BFS. Undirected graph and shortest distance, blindly apply BFS algorithm. Blindly apply BFS algorithm. Shortest path and undirected graph, and as well as unweighted graph. In unweighted graph, undirected graph, and shortest distance, directly, blindly, you can apply BFS algorithm. Okay. So now over here, what I'll be doing. So how will I apply the BFS algorithm? So for that, over here, I need, if let's say I don't have an adjacency list, I don't have adjacency matrix. Do I have an adjacency matrix? No, I don't have an adjacency list nor an adjacency matrix. So is it possible to identify the position of a node? Yes. The position of a node is nothing but its row number and its column number. 0, comma 1, 0, comma 2, and 1, comma 0, and so on. 1, comma 1, 1, comma 2. And this is the position of a node. It doesn't have any kind of name. It doesn't have an adjacency matrix. We don't have adjacency list in our hand. So how will I identify a node? That where is an edge? Okay. So over here, when you will be not having any adjacency list or anything, over that, over such questions, you will be using its row number and column number. So I'll be using the row number and column number, and with the help of the row number and column number, I'll be finding the distance between the nodes, and I will be applying the BFS algorithm. Okay, so how will I apply the BFS algorithm? First of all, how will, let's say, before directly moving on to the algorithm, if I want to apply BFS algorithm, then how will I apply BFS algorithm? So what I'll be doing, I need to find the distance of shortest, I need to find the minimum distance between X and Y. So I can either choose X as my starting point, or I can either choose Y as my starting point. And over here, there are multiple sources and there are multiple destinations possible. Multiple sources are present. Multiple sources and multiple destinations are there. Isn't it? Don't you think? Yes or no? There are multiple sources or starting point, and there are multiple destinations. I can take this as my starting point. I can take either this as my starting point. And if I'm choosing this as my starting point, I can choose this as my destination, or I can go to this destination. So there are multiple sources and there are multiple destinations. Yes or no? Multi-source BFS. Okay. Yes or no? There are multiple sources and multiple destination. Yes. So exactly, if you have multiple sources and multiple destinations, and among all of them, you need to find the minimum one or maximum one, then at that time you will be using multi-source BFS algorithm. A fancy kind of name. It sounds like a fancy name, but it's nothing like different from a level order traversal. A simple level order traversal using BFS algorithm. Okay. So multi-source BFS, multi-source BFS is nothing but BFS using level order traversal. So over here, whenever you see the term level order traversal, you can think of a tree, You can think of a tree. BFS is what it constructs a tree. It constructs a tree of sources and the nodes which are a part of the path from source to destination. It generates an entire tree that contains the source destination and the nodes between the path from source to destination. Okay. So over here we can apply multi-source BFS. So there would be multiple sources. So we need to find the distance between x and y. So I'll be choosing all the positions of x as my multiple source. So what are the positions of x? So it is at present at 0 comma 0 and it is present at 0 comma 1, and simultaneously pay proper attention. I'm writing down the level number. You will understand the significance of finding the level number when I proceed further. So at level 0, I have my source. I have my source and x is my source, and I need to reach to a destination. Okay. And over here, from each node, how many edges are there? Can anyone answer the question that from each and every node, how many edges are connected? At max, how many edges are connected? From each node, in which direction can I move? Now I will be talking in graph terminology, okay? From each node, in which direction can I move? How many directions are possible? 3, 4, 8 directions? Yes, 4 directions are possible. Up, down, left and right. But actually, there are 8 directions possible. Diagonally also, if you include diagonal directions as well, you will be able to see from this node 1, 2, 3, 4 and 5, 6, 7 and 8. 8 different direction. Actually, it's possible that you can include all 8 different directions. But if I talk about this direction, the diagonal direction, I can reach the diagonal in this manner, and if I take this path, then I'll be reaching over here in 2 steps according to the Manhattan distance. And if I move diagonally as well, I'll be requiring 2 steps according to the Manhattan distance. So I'll not be including the diagonal, and hence I'll be taking only 4 directions in which I can move: up, down, left and right. Was this part clear? Why we aren't including diagonal? It was not at all required, and that's the reason we can omit the diagonal as my direction of traversal. Is it clear? Yes or no? Okay, so now I have 4 different directions. Okay, so at each and every level, what you need to multi-source BFS, you need to find out all the neighbors of every node on each and every level. So let's say how many neighbors are there for 0 comma 0. We'll be checking all the 4 directions. Okay, this is our 0 comma 0. Can I move in the up direction? Upwards? No. Can I move in the leftwards direction? No. Can I move in the downwards direction? Yes. What is its coordinate? Row number and column number. It is 1 comma 0. Okay, so this will be at level number 1. The neighbors will be at level number 1. So this is 1 comma 0, and this 1 comma 0 is nothing but O. It is O. It is not our destination. Okay, can I move in the rightwards direction? Yes, I can move in the rightwards direction. What are its coordinates? It is 0 comma 1. But do you think, do I need to go to another source? No, you don't need to go to the another source, because your final destination is y, not x. So you will not be including the nodes over which you have already iterated, the visited nodes, and you will be not going to the source back again. So you will not be going back to the visited nodes. So 0 comma 0 and 1 0 comma 1 are the visited nodes. So I'll be marking the 0 comma 0 and 0 comma 1 as my visited node. So I'll be marking them as red dot. And also 1 comma 0 has been visited because it has been inserted. So from this 0 comma 0, I can move only in the downwards direction 1 comma 0, and I have inserted that node in the upcoming level. Diagonal can be derived from other directions. Yes, exactly. Yes, you Raj. These are the possible additions of integers in order to move in the four different directions. So now let's take the next node, that is 0 comma 1, and let's find out in which direction can we move. So from this node, can I move in the upwards? No. Left? No. Downwards? Yes. So that would be 1 comma 0. So let's insert in the next level, that is 1 comma 0, sorry, 1 comma 1. Okay, and at which level I can move in this direction? Yes, so this is 0 comma 2. So this is 0 comma 2, and let's mark them as visited as well. So this has been marked as visited. Are you getting my point? What we are doing? Is it making sense to everyone? Yes or no? I'm traversing. I'm going to the next level by going to the adjacent node of our considered node, and they will be at a level number 1. So they are going to be at level number 1, and now these nodes have been visited. So now we can iterate over all the nodes of level number 1. 1 comma 0, how many neighbors are there? Okay, so this is 1 comma 0, up, left, right, and downwards. All the three directions are not possible, so 2 comma 0 is the direction in which I'll move forward. So that is 2 comma 0. And now pay proper attention over here, 2 comma 0, and over here, if you if you see carefully, this is y, this node is y, and this is your destination. This is your destination, this is where you wanted to reach, right? This was your final destination. But I will not stop over here. I will try to explain that why this is your answer. The first y, at whichever level you get the destination, over here, this is my level number 2, and I was filling my level number 2. While filling the level number 2, I have reached a destination node. And whenever you find the first destination node, whatever is the level number is your output. I repeat, while traversing and while looking for the destination node, whenever you find the destination node for the first time, at that level, whatever is the level number is your output. That is the minimum distance between x and y in the given grid. Yes or no? Do you agree or not? If you don't, we'll carry forward as well. I'm going to carry forward the test case. I'll traverse all the nodes, but this will ensure you that this is the shortest xy. This is the nearest y from multiple source. Correct? A quick yes or no in the chat box. Yes. So at level number 2, I got my destination node, and this is my output. But let's not stop over here. I will mark this thing as red, that this is my answer. And let's move forward. Let's carry forward. So I'll be marking this as my visited, and all the directions have been explored for this node. Let's see the another adjacent node. Let's explore another adjacent node. So at level number 1, this node was visited. So 1 comma 1, let's find out all the neighbors of 1 comma 1. So for 1 comma 1, this is my 1 comma 1. Up, it is visited. Left, visited. Right hand side, it is not visited, and I'll try to visit right hand side, that is 1 comma 2. I will add it in my level order traversal. So 1 comma 2. and again I reached a destination, and this is the answer. I reached the destination for the second time at the same level. It is possible that you will reach the destination again, a different destination, on some higher number level as well, some higher numbered level as level. I reached the destination, both the destination at level number 2, but it's possible that you can reach the other destinations. There are multiple destinations, right? So it is possible that you reach at level number 4, but the nearest level where you reach the destination is the output. So I reached the destination, and again I reached the destination, so don't worry. So let's carry forward, and this is the another position, another direction in which I can move. 2 comma 1, let's insert it inside the chat box. 2 comma 1, and this is nothing but a 0, and that's it. Now all the destinations have already been explored. If you keep on doing this process, then at the end only a single level will be expanded, one more level will be expanded. So let's see 0 comma 2, how many adjacent nodes for 0 comma 2. For 0 comma 2 I can move the up, left, right, and downwards. No directions are possible. Either some of them are visited or they are out of bound. So now let's explore all the nodes of level number 2. If you keep on exploring the neighbors of level number 1, then over here at level number 3 there would be one more node, and that is going to be your node number this, that is 2 comma 2, and that's it. 2 comma 2 will be at level number 3, and by this level number 3 you will have explored possible all the possible cells of the grid, and there won't be any unvisited cell remaining. So over here, the BFS algorithm, the algorithm ensures you that if you apply BFS algorithm on an undirected and unweighted graph, you will get the shortest distance from source to destination, because the BFS algorithm moves radially. Because the BFS algorithm, it travels radially from source to destination. This is the reason you will get the answer at the earliest level. Whichever level you get the destination earliest, that is the answer for the given test case. So you simply need to do the level order traversal, and whenever you reach a destination, you simply need to return the level number, and that's it. Is it clear? Yes or no in the chat box? Can I get a confirmation in the chat box? A quick yes or no. And after this, I'll be simply writing down the algorithm and then the coding part. But can I get a confirmation? Yes or no in the chat box? Okay. Okay. Thanks, Rishit, for replying. Okay. So now from this, you simply need to know multi-source BFS algorithm. It's pretty simple. It is nothing but, as I mentioned over here, BFS using level order traversal is your multi-source BFS. Okay. So this is what we are going to do. So now let's write down the algorithm. So first of all, I'll be writing down the steps of the algorithm. So over here, what we did, the first step was to include all the X positions or Y positions inside my Q data structure. The BFS algorithm uses a Q data structure. Yes or no? Obviously, we know, if we know BFS algorithm, if we know a BFS algorithm, then obviously we know that it will be using a Q data structure. So what I'll be doing, I'll be inserting all the positions of X in my Q data structure, and along with this queue data structure for BFS, what else do you need? You need a Boolean variable. Bella Shao, bro. Okay, okay, Yuvraj. So, we'll be inserting all the positions of X in the queue. And then what else I will be doing? I'll be needing a visited grid as well, right? So that we will be avoiding revisiting already visited nodes. So now after inserting all the positions, what was our next step? So we started iterating over the number of nodes on a single level. So at level 0, we visited all its nodes. So how many nodes were there? It were equal to 2. And how to find that? You can find that by simply getting the queue size. Over here, what will be the queue? Inside the queue, at the first step, inside the queue, two elements will be present and you will be starting the iteration. So you will need to iterate over two elements of the queue because the insertion of nodes for the level number 1 are done in the same queue, but they have been represented over here at different level. So it might seem that they are different queues, but this is the same queue in which 0 comma 0 is present and 0 comma 1 is present. All the queues are the same one. So over here you need to initially, if you want to shift to the new level, first of all get the size of the queue, then and only then iterate over those many number of nodes, because they are the part of your current level and the rest of the nodes are going to be the part of the next upcoming level. So that is the reason you can get the size. So you will be getting the idea that this many nodes are there on our current level. So I'll be getting the size and I'll be iterating over all the nodes at current level. So this is what I'll be doing. Iterate over the iterate over all the nodes of the queue, over all the nodes, or you can write it down as while the queue is not empty, you can iterate over the entire queue. You can keep on iterating. So this is the basic BFS step. BFS while the queue is not empty. I'll be following this process. So what is the process? So the first point of the process is that iterate over all the nodes all the nodes of the current level. So whatever is your current level, I'll be iterating over all the nodes of that level only. And inside this, I will be insert all the unvisited nodes in the queue. If that node is equal to 0, if that node is not our source, and if that node is unvisited, I'll be inserting it inside my queue because that node can be the path from source to destination. And if the node is the source, if the node is the destination, if I have reached the destination, what I'll be doing? I will be stopping my BFS algorithm at that point itself, and I'll be returning the level, whatever is the level number, I'll be returning it. If and over here I can add one more statement for the clarification, that for each node iterate over all its adjacent cells. So At a current level, I'll be iterating over all the nodes for a current level, and for each node in that level, I will be iterating over all its adjacent cells, and I'll be inserting them inside my queue if and only if they are unvisited nodes. Right? That means if they are unvisited and if it is not our destination, insert it inside the queue. If the neighboring node is our destination, if the neighboring node is our destination, simply stop over here and return the level number. Simply stop over here and return the level number. And that's it. So over here, I haven't mentioned what is the level. How will I keep the track of my level number? So over here, let's say between the point 1 and point 2, you will be defining a variable and initializing its value by 0. So over here, this is initialized with 0 and it indicates that what is your current level. So, and at which point inside our BFS algorithm, I'll be incrementing its value. So over here, at this point, before the iteration of all the nodes on current level, I will be incrementing its value. Why? Because the upcoming nodes will be added at the next level. So this level plus plus indicates that the new nodes are added at the next level. So this is the simplest and short algorithm to solve this question. Is it clear? Yes or no in the chat box? Okay, so let's move forward. So you will be using the simple BFS algorithm, and now over here, in order to implement this, what else do we need? So how will I store the elements inside my queue? So that depends upon the language which you will be using. So let's say you are using Java language, or for Java, what you will be doing, you will be using an array list, you will be using a queue data structure, and that queue will be capable of storing a pair. That pair will be the row number and the column number. That queue will be capable of storing the row number and the column number. That means a pair. Similarly, for C++, you can already, there is an implementation of pair, so you can directly use the pair. But for Java, what I'll be doing, I'll be creating a class which will be called as pair, and that pair's object will be inserted inside my queue. This was all about the implementation part. So for memory, I'll be needing a queue data structure that will be capable of storing an object of pair class or a pair, and I'll be needing a boolean visited matrix which will be having the size n cross m. And what else do I need? And that's it, a level variable that will be denoting what is my current level. Right? So these are the three things which we need in terms of space complexity, in terms of additional space. So now let's move to the coding part, and over there we'll be getting a better idea. Okay, so let's code the entire thing again. So first of all, what else do we need? We need a queue data structure for iterating, right? So I'll be creating a queue data structure, and that queue will be capable of storing an object of pair class. So over here, I'll be creating a static pair class, and inside that there would be row number and column number, and I'll be having the constructor that will be taking two arguments, row number and column number, and this will be used to initialize variables, object variables. And that's it. I have created a queue data structure. So one of my tasks is complete, and I need a visited matrix. So I'll be creating a visited matrix, and the size of the visited matrix is going to be n cross m. It is going to be n cross m, and all the values are going to be false because in Java there is an uh, initialization of false for all the values of a matrix or an array. Default value is false for boolean. So now here starts our algorithm. So the first point was inserting all the x position in the queue. Okay, so for that you need to iterate over the entire grid. I'll be iterating over the entire grid. So two nested for loops are required. Now over here, if at I comma jth position, the value is character x, what I'll be doing, I'll be inserting it as a pair inside my queue data structure. That is the row number and the column number. So I comma j will be inserted, and also as I have inserted anything inside my queue data structure, I'll be marking it as visited. I'll be marking the node as visited. So I'll be changing its boolean value to true. So x, all the x position are present inside my queue, and they have been marked as visited as well. So revisiting will not be the case over here. So now what else do we need to do? So after inserting all the positions, you need to iterate over all the elements of your queue. Yes or no? Till now, was it clear? Yes or no in the chat box? A quick yes or no. This is a simple variation of BFS algorithm. And if you want to know the parent function of this, parent quotient of this, then you can refer Rotten Oranges. It is available on Geeks for Geeks, and it is a very standard quotient that uses the concept from that quotient itself, the concept of multi-source. Uh, you'll be able to understand it in a better way if you solve that question. All the similar kind of questions will be very easy, and you will quickly identify, okay, so this is a little bit modification of Rotten Oranges. So now the next step is to iterate over the all the elements of your queue. So what I'll be doing? So I'll be iterating while the queue is not empty, because I need to iterate. I need to reach my destination as well. No, so I'm not sure that how many at how far is my destination. So I need to keep on going till I reach the destination. So all the elements, all the cells, let them be visited. Let them visit. So now over here, before the point 1 and point 2, I mentioned that I need a level variable in order to store the answer. So this is my level variable. And now what I will be doing inside this, I will be iterating over all the elements of my level. So I'll be getting the size. Currently, whatever is the size, that indicates that at level 0, this many nodes are there. So I'll be getting the size. Now over that many elements only, I will be iterating. I'll not be going to the elements or the nodes of the next level accidentally as well. We don't want that thing to happen. And now I'll be iterating. So I'll be removing the node from the queue. So I'll be storing it inside my some let's say temporary variable, current variable. I'll be removing it. I'll be storing it inside my current variable. And now I can see that I can go in 4 different directions. So how to achieve that direction? So for that, I'll be creating a direction matrix that the top cell is at which position. So I need to simply do column -1. If I want to move in the left direction, I simply need to decrease the let's say column number. In top direction, I simply need to decrease the row number. In downwards, you simply need to increase the row number, and in the right direction, you simply need to increase the column number. So I'll be creating a direction matrix, so that will be helping me to find the coordinate of the next level. So -1 comma 0, and over here 0 comma 1, and over here 0 comma -1. So this is my direction matrix, and I'll be exploring all these directions. Okay, so for that I'll be finding new row and new column number. So new row will be nothing but the addition to the values of a direction matrix. So I'll be iterating over the elements. I is lesser than 4. How many elements are there? 4. So there is a possibility that 4 different edges are possible. So now I'll be finding the new row number, or you can say adjacent nodes row number and column number. So that would be current row number plus whatever is the element at ith position at this will be added to your row number. And for column number, I'll be doing current column plus in the direction matrix whatever I need to do. Either I need to add one or subtract one. I'll be trying out all the possibilities. So first of all, directly moving to that position is not at all safe to do. So what I'll be doing, whether that position or a cell is a valid one or not. So I'll be passing the value, the new row number and new column number inside my function that is called is valid, and the arguments will be row number and column number and total rows and total column as well. If it returns a true that this is a valid position, valid cell, I'll be checking. If it is not visited, no. If it is already visited, then it is not of any use. Okay, if this is not visited, then that's totally fine. Then when should I include this new cell inside my queue? You can only include when the adjacent node is not your destination. If the adjacent node is not your destination, insert directly inside your queue data structure. Okay, so if the adjacent node at the nth row and nth column, if it is not our destination, that means if it is our 0 or O, I will insert it inside my queue. I'll be inserting its row number and column number. Okay, inserted. I'll be marking it as visited as well. Whenever you do insertion of any row number, column number, do not forget to mark it visited. Okay, if this is not the case, then there is a possibility that you have reached the destination. If you are at the destination, what do you need to do? Simply return the level number. Over here, we have not incremented the level number, so we can add the step over here that will be moving to the next level. So from this point itself, I'll be returning the level. So we need to write down our is valid function. So let's write down over here, and it will be returning the row number. It will be returning whether this cell is a valid cell or not. Return if the row number is greater than or equal to 0 and the column number is greater than or equal to 0 and I should be lesser than n, that is I should be lesser than total number of rows, and your j should be lesser than total number of columns. All these conditions are satisfied. It is a valid one. So this name is valid, not visited. Okay, so this will be returning true or false. And over here you have added visited. You need to mark it as visited. So we'll be passing true as an argument. Yes or no in the chat box? A quick yes or no in the chat box. Okay. So now this is our entire solution. If you don't believe, we can directly see this thing, and let's return a simple dummy value has been returned because there won't be any grid in which the destination is not possible. So you won't reach this step at all. Okay, there is no possibility, and also there is nothing as -1 to be returned because there won't be any such case in which all the entire cells are X or the entire cells are Y. So now let's try to compile and run and see the output. Okay. N is already defined. So where is the error? 50th line. Okay. N and M. I accidentally changed this to M. Okay, so we got the expected output, and let's try to submit it. Can you please give a brief about the static class used for the pair class? Okay, so over here, the static, if you know a little bit about static, then all the methods, let's say if you are calling another method, this shortest xy distance is a static method already defined as a static method. So from this static method, if you want to call any other method, then in Java, that method as well should be a static. Over here is valid. If I remove the term static, then it is going to give you compilation error, because a static method can call only other method that are static. Okay, and talking about the class pair, over here, if I don't do this thing, then from static you can't call anything which is not static. Okay, so if you see this thing, non-static variable, from static methods you can't call non-static entities. Okay, so that's the reason you need to add static over here. And this is because in the driver code, the method which might be calling the shortest xy distance might have been defined as static, might have been declared as static. Okay, so the calling of shortest xy distance method has been done from main, and main is a static method, hence this method should be static. Okay, so we already saw the output and on the submission as well. Let me show the submission again. It has been accepted. Okay, and talking about the time and space complexity, can anyone identify what will be the time and space complexity? Till then I'll be sharing the link of this code in the chat box. What will be the time and space complexity? What do you think? So in terms of space, if you want to know the space, I have written down all these three things which are required. So what do you think the space complexity is over here? First of all, let's discuss space, and then we'll be discussing the time. What do you think is the space complexity? If you want to take a look at the code, I can share the code as well. So let's clear it out. So the space complexity n into m. Okay, so let's check. I got an answer. The space complexity is n into m. So over here I have used a queue data structure. So in worst case, I know that there would be n into m number of, in total, how many elements can you insert inside the queue? That would be n into m. That is total number of cells in your grid. That is the maximum number of elements you can insert. And what is the size of your Boolean visited matrix? That is equal to n into m. And this level, it takes no space. It's constant space. So the space complexity comes out to be n into m twice. So you can write down as n into m. And what about the time complexity? So if you pay attention over here, we have used the visited array. So that will ensure that none of the cell is revisited. So from this point, you can directly say that the time complexity is going to be order of n into m, because the visited matrix ensures that none of the cell is going to be visited twice, not more than one. So how many cells are there? There are n into m cells. So the time complexity comes out to be n into m. So this is our time and space complexity. Yes, Rishit, exactly. Is it clear? Any doubt till now? Any confusion in any of the part? Do you guys have any of the confusion, any doubt in this part, in the explanation part or implementation part? A quick yes or no in the chat box, and then we'll be ending the session. Okay, I see no doubts coming. So I think everything was clear to all of you. Okay, so we can end this session here only. It was a pretty good question, and it was a simple variation of some of the standard graph question. And if we know some of the standard question, then it's every time easier. The main intuition for the solution is that when we have distance, we should think of graphs. Yes, you can think of graph. Almost majority of the questions you will be able to use graph, but you need to know how to modify bfs dfs. Okay, and that's kind of tricky, because if you have done graph questions, then you will be knowing that all the algorithms are nothing but variations of bfs and dfs. Everything in the graph revolves around this point, that you need to know bfs and dfs. All the algorithms are nothing but it's different variations. Shortest path, all of them, they are variation of bfs dfs. Okay, so if you practice a lot, then you will be having that skill in your hand, that you will be able to modify it according to the question. Okay, so that was it for today's session. I hope you really enjoyed this session, and you will be able to solve this question, and you learned it in such a manner that you won't forget if this is asked in the interview. Okay, you're welcome, Rishit. Okay, so do give a like to this session if this was informative, and also comment if you have any doubt further. And I'll be adding the link in the comment or the description part as well, the coding part. Okay, so that was it for today's session. Thank you, everyone. Thank you for joining. And yes, so good night, everyone. Bye bye.